Assalamualaikum everyone. Welcome to my video tutorial for physics students. My topic in today's episode is finding the magnitude of the net magnetic field around two current carrying wires. Watch till the end of this video and you will surely learn. The question is, the figure shows two long thin wires that carry current in the positive z-axis. The 50 ampere wire is in the XZ plane and is 5 meters from the z-axis. The 40 ampere wire is in the YZ plane and is 4 meters from the z-axis. Question is, what is the magnitude of the magnetic field at the origin? First thing first, we have the following given data. The current in wire 1, denoted by capital I sub 1, is 50 amperes. And the current in wire 2, denoted by I sub 2, is 40 amperes. We are also given the radial distance of wire 1 from the origin, denoted by R sub 1, equal to 5 meters. And the radial distance of wire 2 from the origin, denoted by R sub 2, equal to 4 meters. And our target variable is the net magnetic field at the origin, denoted by capital B sub net, based on Oersted's experiment. We say that a current carrying wire induces a magnetic field around the wire, and the magnitude of this magnetic field around a long straight conductor at a point a radial distance small r away from the wire can be expressed in the following equation. The magnetic field capital B is just equal to the product of a constant mu naught times the current I divided by the product of 2 pi and the radial distance small r, where the constant mu naught is called the permeability of free space, and that is equal to 4 pi times 10 to the negative 7 power Tesla meter per ampere. We can determine the direction of the magnetic field using the right hand grip rule, which states that if the right hand grips an electrical wire such that the thumb points in the direction of the conventional current, then the fingers, when curled, point in the direction of the magnetic field, which is created by the current. So using this formula for magnetic field, we will now determine uh, the magnetic field that is induced by the current in wire number 1. Alright? So magnetic field B1 is just equal to 4 pi times 10 to the negative 7 Tesla meter per ampere multiplied by the current in wire 1, 50 amperes, all over the product of 2 pi and the radial distance, alright, R1, which is 5 meters. So doing our math, we will get the magnitude of B1 equal to 2 times 10 to the negative 6 Tesla, alright, in one significant figure. So to determine the direction of this magnetic field, we will just apply the right hand grip rule, alright. So when you grip the first wire, alright, your thumb must be pointing upward in the direction of the current. And then if you're going to curl your other 4 fingers, alright, you will curl it in counterclockwise direction. So this counterclockwise direction of magnetic field, alright, suggests that the magnetic field induced around this wire is circular in shape, alright, and part of the magnetic field, okay, that is tangent to the origin or to the intersection of the x and the z axis, all right, you will realize that this uh, tangent line will be pointing into the negative y-axis. So we therefore say that the direction of B1 is that it is directed into the negative y-axis. Similarly, for magnetic field B2, we also calculate the magnitude of B2, and that is equal to 4 pi times 10 to the negative 7 Tesla meter per ampere multiplied by the current in the second wire, which is 40 amperes. All right, all over the product of 2 pi and the radial distance, which is 4 meters. So again, doing our math, we will get the magnitude of B2 equal to 2 times 10 to the negative 6 Tesla. And once again, in determining the direction of B2 using the right hand grip rule, this time you're going to grip the second wire, all right? Make sure that your thumb is pointing upward in the direction of the current, all right? And then if you're going to curl your other 4 fingers, okay, the direction of the curling represent the overall direction of the magnetic field, which must also be circular in shape, all right? Both B1 and B2, all right, the circular loop that we have in this drawing, let it be understood that these circular loops representing the magnetic field lines are actually parallel to the xy plane, all right, parallel to the xy plane and perpendicular to the z-axis, all right, or perpendicular to both wires, wire 1 and wire 2. So, part of the magnetic field induced around the second wire, all right, the one that is tangent to the origin, all right, you will realize as well that the direction of the tangent line is it is directed into the positive x-axis, right? And that means that um, with B1 directed into the negative y-axis, while B2 directed into the positive x-axis. That means the two magnetic fields are perpendicular to each other, or that they form a 90-degree angle. All right? And determining their sum, or vector sum, which is our target variable, all right, we call it the net magnetic field. Okay, we will be using the Pythagorean formula. All right, that is, B net is just equal to the square root of the sum of the squares of the two magnetic fields. All right, since they both have the same magnitude, so we just have it here. For B1, 2 times 10 to the negative 6 Tesla, that will be squared, plus B2, which is also 2 times 10 to the negative 6 Tesla, to be squared. All right, and we can simplify it to square root of 8 times 10 to the negative 12 power Tesla squared. All right, so using your calculator, we will get the final magnitude of the net magnetic field equal to 3 times 10 to the negative 6 Tesla expressed in one significant figure. All right, that is what the question required us to determine, just the magnitude of the net magnetic field. All right, already shown in the figure are the directions of magnetic field B1 as well as magnetic field B2. All right, since they are of the same magnitude, all right, and that they form a 90-degree angle, what do you think is the direction of this net magnetic field? So that's the challenge question for you. All right, if you know the answer, just drop it in the comment section. So that's it. We are done with our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.